Hello, I'm Zach. I make graphics for the New York Times. I was going to present with Adrian Blanco Ramos. Unfortunately, he couldn't make it today, but a lot of this is his work as well. He'll be in the Slack as well, answering questions and posting links. So if you want to follow along the presentation, we've made this notebook public. So you can use this link at the top of the presentation. Hopefully Adrian will post it in the Slack as well, so you can all take a look. So today I'm going to talk about making maps in Observable, which is a web-based browser tool for making, really for data visualization, but you can also make maps and all sorts of interactive graphics as well. Both Adrian and myself have used this tool a lot to make maps for publication, both for sort of iterating on designs, for trying different screen widths, trying different thematic map representations. And it's really helpful for, it's kind of like a Google Docs type tool, so you can work together collaboratively, you can share code, you can duplicate code, import other people's work. So to start, I'll show some examples of what we've done with this. So these are all in different forms made in Observable and then exported to a different drawing tool like Illustrator or just built in the web natively. So Observable is built on JavaScript, which is, if you don't know, it's kind of the primary coding language on the web to do anything interactive or anything special beyond HTML. And while JavaScript is necessary knowledge to use Observable, we're providing this notebook publicly, so you can basically just use the code we provide and then tweak little things, as I'll show, to fit your use case. What makes Observable really useful is that, one, it's collaborative, so you can work together with other people in the document. Two, it kind of provides a really cheap way to iterate on designs. You can make maps that in different forms in the same notebook. And you can do a lot of sort of special thematic mapping techniques as well. So a lot of this I won't go into in detail. You can follow up after to either ask questions or really just go into the notebook to see what we've written. But I'll kind of explain a few major points on importing data, projections, styling data, thematic mapping techniques, and then exporting. So in general, when we use Observable, you're going to be using either GeoJSONs or TopoJSONs, which are basically another form of data structure that is made for JavaScript. It's very easy to convert things like shapefiles to JSONs with tools like MapShaper or in QGIS. And you can see, so basically we've imported here some data sets up in the top right corner with the attach feature. And then basically you just import them into these little blocks that are the building blocks of the notebook. And if you look at the structure of this, you have the sort of topology object, and then within it, we have objects, counties, and states. And then within those, we have geometries that have our spatial data. Yes. How's that? Cool. Sweet. So once we've imported our data in these blocks, we can, so here we import like with a US shape and then sort of break that down into states, and then we also have counties as well. And so there's a limit to the amount of data you can load in Observable. Right now it's 50 megabytes. So if you need to sort of simplify data, you can use tools like QGIS or MapShaper. Here I'll be talking about how to make maps in JavaScript using D3, which is a data visualization library that provides a lot of functionality, both for data visualization, but also has tools for projections and visualizing geographic data. So the building blocks of that are these projection tools, which basically allow you to define a projection type, define the window that you want to fit it into, define the zoom of the map, and then define sort of how you want to shift it within the window. And then once you have a projection, you can create a geopath, which basically tells D3 how to draw your shapes in the map. So here's an example of a very simple map using the data that we've imported. And so we can see down here, here's kind of the building blocks of how a map is rendered in D3. D3 uses SVG, which stands for Scalable Vector Graphics. It's kind of just a way to create vector shapes. And sort of the idea is you create an SVG and then append paths to it that are built on your data. So a lot of this code is kind of opaque and might not make a lot of sense to you, but how I usually use Observable is sort of copy existing code from other people's notebooks, because a lot of these are public, and just paste it in and change what we're doing. So here we use our data, which is our states file that we defined earlier, append a path, put our projection here, and then we can change our styling down below. So if we wanted to have, red fill, we can change that. If you want to change the fill opacity, you can use different commands to change our styling. And what's really nice here is that if you want to sort of iterate on designs or have different versions, you can just copy all this code, paste it in a new block, and it'll make a new map right above it, with a different opacity or a different style. And then what's really nice is you can just add additional layers in the same block. So if I just uncomment all of this, we can add all of our counties to the map. And then do the same kinds of styling that we would do with any tool. A lot of the styling functionalities are sort of what's built into something like CSS. So you can do a lot of, it's somewhat basic, but you can end up doing a lot of sort of advanced stuff with different layers and more advanced things. Another really nice part of Observable is the ability to directly manipulate data using code. So for example, here I've brought in a county data set which has the area of water and land in each county. So if I just iterate through all of these for each county, I convert what was in square feet to square miles, or maybe square meters to square miles, and basically return those properties to edit the file. So here we brought in data to look at the number of lakes in Minnesota, fitting. And so for example, here we've filtered our counties file to only look at Minnesota. We've created a new GeoJSON, changed our projection. So here, instead of using a GeoAlbers projection for the US, we use a conic conformal, and then you can edit the details. I didn't make this up myself. This is from someone online has put sort of state projections in D3 for every state, and there's a link somewhere else in the notebook to grab these. So then we've created another map block with the state of Minnesota. And as you can see, it's very similar to the other one, except we've changed the data to our county select file, which is only the counties in Minnesota. And with our projection, we've changed the area that we're looking at in the map. So this is probably the most exciting part of Observable, which is the ability to do really quickly try out different thematic mapping techniques. So we have a few examples here. So here, you can just sort of visualize the lakes in Minnesota to see, as you would in any other mapping platform. So basically, we're in the same way that we brought in our counties or US data set earlier, bring in data, filter it, and sort of adjust our projection to fit that. And you can see the block is pretty much the same thing. We change our data to lakes geo and change our fill color if we wanted these to be, a different blue and a little bit more opaque. You can change that. That looks a lot better. Cool. So then in terms of doing other kinds of data thematic mapping techniques, we can do things like choropleth. So this is the percent of area that is covered in water in each county. So you do that by sort of defining a color scale using D3 and defining that in the fill property of the map. can also do proportional symbols, like a lot of tools. You do a similar kind of scale with the size of the dots. So here you can see that we've created both the base map, which is this block here, which is like the counties in the background, and then above it we have a separate layer of the SVG, which has, instead of it appending a path, like the shapes, we append circles. And there's sort of different attributes you add to those to make them work with the data. So here, for circles, for example, you add these like CX, CY radius properties to define the center of the circle, how big they're going to be, and then the styling. Another really helpful tool that I've used in a number of maps is force dots, which is hard to do in something like QGIS, which basically allows you to do a look like this, to sort of like pack dots into an area based on some kind of data. I won't get into too much of the details of how this is done, but if you want to do this, you can kind of go in here and grab the data. So basically, we have this apply simulation function, which does a lot of work for you. Of basically, you tell it, I want to put 35 dots in this square, and packs them as close to the center as possible. We can, in the same way, these are all built on kind of the same structure, so you can really mix and match different styles on top of each other. You can, style certain dots to be different colors based on properties to, fit whatever your map is going to look like. So I'm going to show an example of this in practice. This is a project that Adrian and I worked on last year to look at no internet. Oh, I have it open. Nice. So this is a project that Adrian and I worked on when the census results came out last year, looking at sort of demographics by county and how things had changed since 2010. So these maps were actually built in Observable, and unfortunately for some reason this isn't loading, but we have a whole notebook where we tried out different styles to show how things look. We tried out different colors. We tried out different representations. We ended up going with these sort of mountain shapes. This is basically all built in Observable and then ported over to a template where we could show it on the web. As well as this sort of interactivity, you can do hover over it, tooltips, and all sorts of things. And then in this story, basically what we did is then filter out the data to show for each demographic group how things had changed across the country. In that notebook, you can see, if you go to this link, you can see sort of how we did that. And there's really nice ways to create drop-downs and different tools to help people navigate what you're working on and see different representations. And then, so finally, once you've created your map in Observable, there's a couple ways to export them. This is a good reference for in the future, but for the purpose of the presentation, basically, you can export as PNG or SVG files. So you just go to these three dots in the left-hand corner of a map. For example, this one, you can download it as SVG, download as PNG. You can also embed it. So if you have a web page you want to embed this in as a frame, you can just click embed and you get a link that you can embed in a web page. And what's really nice about the exporting is that kind of like, however you sort of structured it in the code, it'll end up that way in Illustrator. So if you download as an SVG, it has groups based on your thematic data, your background data, and it's all sort of within a window that you can use. I'll show a couple more examples that we've done in the last minute or so. Here's an example that Adrian made for the post showing where Trump and Pence had traveled on the campaign trail using that sort of force dot styling. Here's a map I made for the Times showing confirmed killings and disappearances by the Taliban. So this was basically, I made the data layer and the counties in Observable and then overlaid that over a hillshade to kind of give it more style. But in this project, the data was changing a lot, so you kind of input data over and over to once reporters came up with new data. It was really easy to then export it, bring it into Illustrator, and overlay it. That's all my time. Thank you very much. And I put contact information at the bottom. If you have any questions, feel free to reach out. Thank you.